Yesterday, I thought was a pretty good day. Number one, there was a lot of algebra, and there was a lot of the calculator stuff that you're reviewing. And I keep saying things, because I want you to do well when you take your placement test or your standardized test. All right. And again, a lot of this stuff, you take Algebra 2 because it's a complete repeat of Algebra 1, the first semester. All right, so you'll be seeing it again. All right, but I do think it's important that you refresh periodically. That's why I decided to take the day yesterday to kind of review everything with you. All right, some of you guys definitely need to work on, the algebra stuff. And you need to be familiar with the graphing calculator. I work with a lot of kids, and I say you're at a big disadvantage because no one ever showed you how to use the graphing calculator. The graphing calculator is a powerful tool. If you know how to use the graphing calculator on the SAT, you get to use it for half the test. On the ACT, you get to use it on the entire test. All right, and some kids don't know how to use the calculator. All equations can be solved using the calculator. All right, and so you have a big advantage if you forget how to do something. All right, a lot of the graphs, they say, what does the graph look like? All you have to do is type it on your calculator and look at the graph. But if you don't know how to use the graphing calculator, you wouldn't know to do that. All right, so we got a little behind. So tomorrow we're kind of holding off on the quiz, and part of the reason why I don't really like giving quiz on Thursday because we have a shortened period anyway because of long service, and so it's kind of challenging for me to do that. So I was going to give a quiz in just over 2 sections, but Friday unfortunately is a service day. All right, so we're not even in school on Friday. So that's the problem. So we're going to have to really kind of postpone it, and we'll have a quiz next week, and we'll kind of add to it these 2 sections. And probably tomorrow is going to be kind of an easy day because instead of doing a quiz, I'm going to probably find some IXL stuff to do, right, that will reinforce the circle stuff because it's been a while. And that would just be an easy grade. You won't have any homework over the 3-day period, so it should be to your advantage. Now, today is what I would consider another tough day because I have to show you some old algebra stuff. The concept is very easy, but there's only one problem, all right, that's difficult at all. And the reason, normally in the past, I've kind of just said this is an Algebra 2 topic and it doesn't matter, but I know it's on your SAT. And for those of you guys who eventually will be striving for your national merit finalists, all right, and some of you will be, all right, then this is a big part of the SAT that can get you some recognition. So I want to start right now and make sure you understand what we're doing. All right? So this is a big part of your SAT. Yes.
What's the national merit finalist?
Well, it's the top. You're in the 99th percentile. As a student, in the nation. All right, that's what you're striving for. All right, so when you take the SAT and ACTs, they have percentile. And if you get high enough scores, you're recognized. And then when you go to colleges, believe it or not, colleges will pay you to go to school at their college because they like to say that we have so many national merits at our school because that's just something for them to brag about. They have the top kids in the nation. All right, what? Absolutely, yes. All right, and again, we've had a lot. All right, we've had a lot from St. John's. And like I said, right now, the thing I'm telling you is you don't know about it right now, but trust me, all right, it is a big deal. It's a big deal for your parents. It's a big deal for you. It's a really big deal for St. John's because we looked at the national merit finalists and out of all of the kids, I think we had 7 or 8 last year, right? Which seems like that's, not a big number, But there isn't a big number in Hillsborough County that are National Merit finalists. So when you look at the overall statistics, I think we were 10% of the National Merit finalists.
In the entire country?
No, in Hillsborough
Oh,
County. Right. No, in Hillsborough County. All right. So again, the National Merit finalist just means that you're the top, you're in the 99th percentile, which means you're better than 99% of all the people in the country. All right. And that's kind of a big deal. All right. Right. Exactly. Okay. So that's what we're striving for. All right. That's what we're striving for. All right. Now, again, yesterday we made kind of an introduction to it, so this should not be a big deal. All right. If you recall what I said yesterday, I want to write the general form up here for you. The general form would be x minus h squared plus y minus k squared equals r squared. We said h and k are the center and r is the radius. All right. So if the center's at the origin, I'd like for you to put down 0, 0, and r equals 6. So the equation of the circle would just simply be x squared plus y squared equals 36. Any issues with that? All right. So then, question number 2 would just be the same thing except, right, so it would be x squared plus y squared equals 4. All right? Yes?
What are
H and K is, for whatever reason, H and K were defined as the center. I don't know why they chose H and K. But just remember, it's kind of in alphabetical order. H and K. H goes with X, and the K goes with Y. Yeah, all we're doing is writing the equation. All right, all we're doing is writing the equation. And I guess what I'll do is today, maybe I'll have time on your calculator. I'll show you how to plug this in on your calculator so you can see that it is a circle. All right, because right now it doesn't look like a circle. All right, most people don't know why. I could show you quickly, but it's not important. All right, what is important is that you know what the equation is. All right, so now if the center is at 4, 3, it would now be what?
X plus 4.
Wait a minute. Remember, it's minus, so that just means they're opposite.
X minus 4 squared plus y minus 3 squared equals 1.
That's how simple. That's all there is. Nope, that's the answer. All right, that's the answer.
That's straight.
All right, so number 4 we have as what? Come on, guys.
X minus squared plus y minus 1 squared equals 144.
Was 144. All right. Because again, the diameter this time is 24, which makes the radius 12.
Yeah, the diameter.
Yes.
How come for 1 and 2 you like simplified it? Is it just because it was 0? You don't want
Well, x minus 0 is x. X minus 0 is x. Boys, listen, Chancellor, you're distracting me. I'm not sure what's going on back there. I'm talking and you're looking up and you guys are, I don't know. All right, that's okay. I'm saying I don't know. I'm just saying I'm looking up and you just so happen to be over somewhere else. Sorry, it wasn't you. All right? Doesn't matter. All right? Now, we're going to skip number 5 for a quick second. All right, I want everybody to tell me about 7. All right, first tell me what the center of that is.
2, 3, 2.
And the R is,
2.
and the radius is 2. All right, so now we go
X plus, or minus
X minus 2 squared plus y minus 2
was
squared
equal to 4.
equals 4. That easy. All right,
Oh, Mr. Stroud,
yes.
is the radius? Never mind.
What?
How did you find the center?
I looked.
Oh, I'm looking at the number 5.
All right, we're on 8. All right, the center of the circle is what?
0.
Hold up. Chancellor, you good with that center?
Yeah.
All right, thank you. What's the radius?
X
Radius is what? 3. All right. So my equation is
Squared plus y minus.
Y plus 3. Y plus 2. Oh, it's 0, negative 2.
I wrote 3 on mine. Oh, that was easy. Okay. All right, here we go. Number 9. So now we're just graphing. All right, we're just graphing. So if here we have the center is what? 0, 0, and the radius. And the radius is 4.
Oh, no.
All right, so
Oh, no.
you just go up 4, to the right 4, down 4, and left 4, and then let's see your circle.
That's pretty cool. Wait.
Oh, Mr. Strong.
I
remember, Jordan came home one day complaining that you gave her like a lower grade on a test and she got a higher grade because she was able to draw a better circle.
Absolutely. All right, here we go. So the center of the circle for question number 9 or 10 is what? 1, 4 with a radius of 3. All right, so here we go. 1.
This is like grabbing less.
Easy as that.
What are the things called?
Oh, they're called compasses.
Now, now I want to go back to question number 5 now. All right. Again, number 5, not that difficult. They don't give us the radius or the diameter. All right. So what I want to show you now is if the center is -4, -1, you would be saying that it's x plus 4 squared plus y plus 1 squared equals r squared. All right? So we're missing r.
So now you have to solve.
Now, what we're going to do now is we're missing r. All right? So one of the things that comes up a lot on standardized tests is they give you what appears to be some random point. All right? And what I want you to try to remember is that random point is the x and the y. Do you agree?
Yeah.
So in order to find r, I need a what? X and a y. All right, so what I'm trying to show you is this right here. Please look. If I know x and I know y, I can figure out what r is. Think about what I just said. I have x, y, and r. I don't know r. So the way I can find r is if I know what? X and y. Do I know an x and y?
Yes.
So what do I do with the x and y? All you do is plug them in. Now, again, because we're brilliant, we can kind of do mental math in this situation. -2 plus 4. 2 squared. 3 plus 1. 16 plus 4. 20. So now listen, I don't care what r is. I care what r squared is. So it says here that r squared was equal to 20. Does anybody have any objections to that?
No.
R squared is equal to 20. Because r squared is equal to 20, I can now move that out of the way and put in 20. And that is the equation. All right, that is the equation. That's how simple it is. You're missing r. So you plug in for x and y. It doesn't matter what x and y as long as it's on the circle. That will help you figure out what r is. All right, what? No, I can't go slower really. I plugged -2 in for x. -2 plus 4 squared. Now I plug 3 in. 3 plus 1. 3 plus 1 is 10.
Yeah. Oh, sorry. 4.
Squared.
16
Plus 4.
16 plus
4 is brilliant. You're with me.
Okay.
Go, come on.
So Is your answer X?
That is my answer. I'm looking for the equation of the circle. That is the equation of the circle.
Is there any reason why you don't plug in X and Y?
Yes, because if I plug in x and y, I'll get 20 equals 20. That's not an equation of a circle. The equation of the circle is x plus h squared plus y minus k squared equals r squared. All right? So here we go with question number 6. All right? So again, the center's at 5, negative 2. So I can go x minus 5 equals r squared. I'm missing r. All right? So now I'm plugging in 4 and 0. If I plug in 4, 0, negative 1 squared, 1, 2 squared, 4 plus 1. So r squared equals 5. So my equation now is just x minus 5 squared plus
Y plus 2 squared is equal to 5.
yes. Simple as that. All right, really, it's honestly very simple. Very simple. All right. Now, a little bit harder. All right. Now, this would not be easy if the points were not either vertically or horizontally attached to each other. Because if the 2 points are vertically, well, you'll see what I mean in a second. All right, you'll see. So, yes, it says plot negative 2, 3. And then you're plotting 1, 0. And then you're plotting 4, 3. All right? Does everybody see what I'm getting at now?
Oh, so now it would be.
I think this is the center of the circle.
Yeah. So wait.
Now, the reason I know it's the center of the circle,
Radius is 3, so just go up 3.
from here is 3, from here is 3. Yes. All right. But that's not the most scientific, that's not the best mathematical way to do that. But right now, it works. All right, because this distance is what? 3, 3, 3. What?
Why is C
It's at 4, 3. Right? 1, 2, 3, 4. 1, 2, 3. What?
If the two horizontally are both equal to the radius, that means the one below and above.
Yeah, that's what I'm saying. It will have to be that way. All right. If this point, for example, just listen to me now, guys, because that's not that hard. Let's say it worked out like this. Let's say the other point was over here. It's a lot harder to find out the circle now. All right, a lot harder. Actually, we just find the perpendicular bisectors, but it doesn't matter. All right, they made it real easy right now to start out. All right, so let's go back now, and we realize that the center of the circle is at what?
1, 3.
At 1, 3, and then the radius is
3.
So the equation,
X minus 1 squared plus y minus 2 squared.
simple as that. All right, I don't care about number 12. I need to get something a little more challenging. All right, so here's what's a little bit more challenging. All right, and we'll work on this more tomorrow, but because there's only one example, so we're going to come down to the bottom here, and we're going to do this problem. All right. All right, so there is my equation. All right. Now, again, last year in algebra we learned something called completing a square. All right, I'm not even expecting you to remember it. All right, I'm asking you to just kind of pay attention and hopefully we'll come back to you in a minute. All right. So the reason why I said that was important last year is because most of the time we don't solve quadratics by completing a square. but you do transform conic sections, which are parabolas, hyperbolas, circles, and ellipses, into what's referred to as center form or vertex form. All right, so in order to do that, you have to know how to complete the square. All right, we are trying to convert this equation into x minus h squared plus y minus k squared. That's what we're trying to do. All right, it's very simple. All right, so first and foremost, you have to put the square terms, you have to put the x terms together and the y terms together, and you have to move the constant to the other side. All right, so when I do that, it becomes x squared plus 6x, and then last year we just did it with x squared. So we only had to have space for 1. All right, but right now we have an x squared and a y squared. So you're going to put x squared plus 6x, leave a space, and then it's going to be plus y squared minus 6y equals negative 9. All right? Anybody have any problems with that? Again, all we did was we grouped the x's together and we grouped the y's together. That's it. Now, right now, hopefully you see, well, that makes sense because the x squareds and the y squared. All right, they're separated. All right. Now, in order to complete the square, the rule is you always take half of b and then you square it. All right. Now, what is b? B was y equals ax squared plus bx plus c. B is always the number in front of the x term. So in this case right here, b is what? 6. So we take half of 6 and then we square it. So that would be 9. All right? So we're adding 9, right? And if I put a plus 9 on the left, I have to put a what?
Minus 9.
Plus 9 on the right. All right? We're putting a plus 9 on the right. What?
Why do you have to add b?
Why do
Why
I
do you
have
have to add b over 2 squared?
Because I'm trying to make it a perfect square.
Okay.
All right, you'll see in a minute. All right, you got to let me finish now. I promise you, you're not going to see the whole thing until you let me finish. All right. Now we're going to do the same for the y values. Negative 6 divided by 2 squared is what? 9. So that's plus 9, and that's plus 9. Now, the reason why we complete the square is because that creates a perfect square. All right, what does that mean? That means that x squared plus 6x plus 9 is a perfect square. Now, if you were to factor that, that would become x plus 3 times x plus 3, or it would be x plus 3 squared. And all I'm trying to tell you is that, remember, when you're factoring into a perfect square, it factors into whatever the half was. What was the half of positive 6?
3.
Positive 3. So that factors to x plus 3 squared. What was the half for the y's? Negative 3. So that would factor to, y minus 3 squared. And then you simplify the right side. Negative 9 plus 9 is 9. All right? So now I have transformed x squared plus y squared plus 6x minus 6y plus 9 equals 0 into a form that you can recognize and now say that the center of that circle is at negative 3, 3, and the radius is what? And the radius is 3. Yes. No, you're doing exactly what I just said. Exactly what I just said. All right, here we go.
Why did you go from negative 9
Are you asking me what this sum is here?
Yeah. Oh wait, never mind. Sorry. why didn't you do? I know how you did the.
All I want is the question.
Couldn't you just add any number?
If listen, once again, let's refer. Listen, I don't normally say this. If there was a better way, or a shorter way, or some other way, guess what? I would promise you. I would tell you. I always try to show you the quickest, easiest, most efficient way to do it. That's what you have to do every single time. There's no alternative. Nothing is easier. That's what you have to do. All right? Now let's do one more. All right? Here we go. So I want everybody to try to break this down. X squared plus 8x. Uh-oh. No, let me just do this.
Are you writing the quadratic?
Yeah, I'm trying to make one up here. X squared plus y squared plus 8x minus 10y. Oh, shh.
Are we just setting it to 0?
Yeah, that should work. All right, try to find the center and radius. Try to find the center and radius of that equation. All right, that's what you're working on right now.
Oh, you do the same thing we just did, right?
Same thing you just did.
I can do that. I can do that.
Ryan, once you get the answer, good luck.
It's not his answer.
Oh, I hear.
Okay. I got the answer.
I got the answer.
What is it?
Wait, don't say it. Wait till like everybody's done.
You say that would never happen.
You want me to say it?
Yes.
No.
Go.
Hayden, if you say.
I'm not
Hayden,
saying
there
it.
will be Hayden.
I'm listening.
No, don't say it.
I mean,
I don't care. Just tell me. Who cares?
Everyone cares.
No. Oh, are they going to beat you up?
Yes.
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 Hey, you like to tell us?
I'm not going to say it.
I know
Wow.
I'll say it.
Wow.
If
No,
the center
Ryan.
is negative 4.5, and the radius is the square root of 4.
No, I'm just asking.
Hey,
I don't have the answer.
Radius?
The radius is the square root of 41.
The square root of 41. Where are you getting the square root of 41?
No, that's no. I added 16.
I added 16, 25
Plus 8, 49, 7.
16 plus 25. 16
plus
plus
25.
25.
Calm down.
Plus 8 is 49.
Wait,
but why isn't it? Why isn't it
All right.
49?
Oh, there was
Here we go. Here we
Ah.
go. Again, you're writing x squared plus 8x. Leave yourself a spot. Plus y squared minus 10y. Leave a spot. Equals h. Now listen. All right. Now from there, you're supposed to recall you're taking. Just listen. You're taking half of the middle term, which is 4, and then squaring it, which is 16. So this would be plus 16 plus 16. And then from there, all right, we're taking half of 10 and squaring it, which is 25.
So you're not doing negative? Oh,
Plus
well, that
25 plus
Yeah.
25.
So it's coming
And now what we're doing is we're factoring. Remember what I said? It always factors into whatever the half was. So in this case, it would be plus 4 squared plus y minus 5 squared equals 49. So you would say the center
negative 5,
and r equals 7.
I get this.
Okay.
Good.
So why is it that don't you make like when you put them in like the little don't you make them like negative? And like opposite?
No. So what I'm saying here, remember, what I'm trying to say is, when you factor this, oh my goodness, I'm trying to, hey, I'm taking half of the middle term. Half of 8 is positive 4. Half of this negative 10 was negative 5. That's how I know what goes there. All right? When you square it, it's always positive. All right? That's why you're adding it over to the right side. It's always going to be positive. It will always factor into whatever the half was. All right? That's the easy way to remember that. What?
I understand everything before the equals 49 part. How did you get that?
How did I get 49?
Yeah, you just add up 8 plus 6 plus 45.
Try that and see. What?
So like to find out like the x plus 4, like you don't really even need to do the square unless you're like.
Well, no, but I'm saying they're going to ask you what is the equation.
Yeah, I know, but unless like just to find those, you don't really need to.
I'm not. Look. You can do it however you want. I'm just simply saying that's the order in which things should be done. What?
What if the x squared plus 8x plus 2 like didn't factor perfectly?
Oh, it's not always going to factor perfectly. It will always factor into whatever that half was.
So it doesn't matter the quadratic.
No, to make something a perfect square, it's always, to make something a perfect square, you take half the middle term and square it. It will always come up. Now, this right here would be a little bit harder if it was a 7. Because then you would just say half of 7 squared. Well, half of 7 squared, you just leave as 7 over 2. Then you say it's 49 over 4. Right? So then you could have fractions as part of the center. The radius could work out to be the square root of 41. The radius doesn't have to be a perfect square. It's just the numbers that I'm putting up here try to make it a little bit easier. All right, but if we wanted to, we could convert the 8x to a 7. All right, it's not that much harder. It's just you leave it as a fraction, 7 over 2. You can square 7 over 2 a lot easier than you can square 3.5. Right? So again, that's the technique for that. All right. Now, how much time do we have? All right. So again, what I will do is we'll just go back now, and I'll have you do the second worksheet. All right. You'll do the second worksheet. Yep. 10-8. Now, before though, there's something comes up which is pretty nice. So everybody take a look at number 9. All right. Now, one way of looking at this is just looking at the graphs. All right. So for question number 9, all right, I have y equals x. All right, and I'm trying to find the point of intersection. So I have a circle that looks like that, and I have a line that looks like that. So how many points of intersection are there?
1.
Oh,
I'm not sure why you're.
5. The line's intersection.
7. It's
7.
7.
7. I still say 4.
I said 7.
7.
Why 7?
Oh, 2.
Well, I thought it intercepted like
3.
that circle.
Okay.
Only one place, so it's 1.
6.
2.
6. 1, 2, 3.
There is the circle.
3.
There is a circle, and there's a line. How many points of intersection?
1,
2.
Also with a circle.
Oh, and that.
I'm looking at the
Yeah,
circle.
So it's 6.
So I'm saying that this right here is a point of intersection, and that right there is a point of intersection. So you're trying to find those 2 points of intersection. So the problem I have is I have x squared plus y squared equals 25. Right, so I can't really solve that. However, I do know that what? The y equals x. So wherever I put a see a y, I can put what? X. So I now have x squared plus x squared equals 25. Oh, then you just go to the class.
X equals 5.
Brilliant. All right, x squared plus x squared is 2x squared equals 25. You cannot take the square root through addition. All right. So x squared plus x squared.
And then x squared, and then take square root of the other x squared.
Genius.
Wait, why not?
Oh, you're gonna do that whole process of like multiply the denominator by like the date or not. Yeah, you're gonna do that.
So the x coordinate. So the x coordinate is plus or minus 5 divided by the square root of 2. Now, we don't normally leave our answer as 5 divided by radical 2, so we would leave it as, right, exactly, 5 radical 2 over 2. All right. Now, from that, I need the x coordinate. I need the y coordinate. So,
It's the same.
the y coordinate from the original says y equals x.
So it's the same thing.
Right? So the x and y coordinate are the same. So the point of intersection would be 5 radical 2 over 2, comma, 5 radical 2 over 2.
How is that like possible? How can you plot that?
Well, because, listen to me now. The thing you're thinking of is that everything lands exactly on a point.
But like how's a radical point?
I'm saying, in your head, you want the answer to be exact, right? And not all points of intersection are going to work out to be a nice number.
Okay, but like, isn't that just like the term graph? Like if you're spacing like the grid is bigger or smaller?
No, I'm not arguing with you. I'm simply saying, I don't care how big your graph is. The graph of x squared plus y squared equals 25 is going to be a circle with a radius of 5 centered at the origin.
Okay.
Right? So if we were to graph that, here's one right over here we could use, right? So 1, 2, 3, 4, 5 would be here. And then 5, I think, would be over here, here, and here. So if we were to draw a pretty good circle,
You're a good circle drawer.
all right, now what you're doing is you're drawing the line y equals x, which is not an easy thing to do. Yes. All right. So the solution, what I was trying to tell you is the solution is this point right here and this point right here. It didn't work out to be some nice number. All right. In the past, well, that's what we do. We always make it simple at first, and then as you're progressing, it gets a little bit harder as far as the numbers go. All right. It just so happens that that point right there, if somebody were to type in 5 radical 2 divided by 2,
I know what the answer is.
if you count over 3.5, 1, 2, 3.5, and you go up to what he's saying, that is about accurate. All right? It's hard to look at that number, 5 radical 2 over 2. Most people aren't even sure what that means. All right? But you can look at that and say, radical 2 eventually. All right? You can just get a good decimal approximation for that. But you can literally just type it in. 5 radical 2 divided by 2, and you'll see that's pretty good. All right? That's pretty good. All right? So again, that should help. So tonight, listen, do the second worksheet. All right? Do the second worksheet. And then tomorrow we'll take another kind of finish off this section. And then next week we'll have a quiz on Friday. All right, we're going to go into the next chapter.
A quiz or test. And then all the stuff that we're doing next week here, we get an answer. A quiz or test.